Get ready for the Extraterrestrial Highway with epic views and stellar science. That's all coming up right now on Wild Nevada.
Support for PBS Reno and Wild Nevada comes in part from the William N. Pennington Foundation. Bill Pennington was an entrepreneur, philanthropist, and gaming pioneer who built a legacy of community service in Nevada.
And by Thelma B. and Thomas P. Hart Foundation, Christine Perry, Margaret Burback, Mark and Susan Herron, in memory of Sue McDowell, Lloyd Rogers and Gaia Brown, Stanley and Neela Schumacher, and by individual members.
Hi, I'm Chris Orr, and this time I'm on a popular Nevada highway. That's Highway 375, the Extraterrestrial Highway, and I'm going to actually travel it twice. Once for some alien-themed fun, and once to get a little more in depth about some of the science and history in the area. That's a lot of traveling, so let's get going. Nevada State Route 375 was officially named the Extraterrestrial or ET Highway in February of 1996. To capitalize on decades of UFO sightings, reports of mysterious lights, and of course, the route's proximity to the top-secret Area 51 military base. The highway runs from Warm Springs east of Tonopah to the junction of US Highway 93 in the Hyco-Alamo area. We can neither confirm nor deny any encounters with alien spacecraft or top-secret technology, but it is indisputable that my voice was abducted by some sort of strange force while we were traveling along the highway. However, being intrepid cosmic adventurers, we didn't let it sideline our fun. Little green men or not, with only a few hundred cars traveling from Tonopah to Alamo daily, the ET Highway is a bucket list route for many Nevada explorers. But be sure you don't become too distracted looking for the UFOs that you don't pay attention to the fact that 375 is an open range highway, and the cows do often tend to wander out onto the road. Be sure to keep an eye out. Though alien-themed road tripping on Highway 375 is fun, there is much more to this part of Nevada. So to get to explore some of the very real science and history in the area around the Extraterrestrial Highway, I meet up with Taylor Wilson, a nuclear physicist, science policy advocate, and podcaster. Well, Taylor, we picked a cold day to meet.
It's a little chilly out.
So why are we starting our trip here in Tonopah?
Okay, so we're here in Tonopah, and I wanted to stop at this mural because that aircraft up there, that weird-looking triangle aircraft, might be behind some of the mythology of Area 51 and the Extraterrestrial Highway.
Why?
Well, that's a very weird-looking aircraft. Of course, the F-117, the world's first stealth fighter. It was developed at the infamous Area 51 Groom Lake Test Facility, and then its first operational squadron was not far from here, down at the Tonopah Test Range. It's funny, for an old dusty mining town, Tonopah has found itself at the center of aerospace history many times. And this all kind of started during the Second World War, when Tonopah Army Airfield was the center for training. So you had people with fighter aircraft and bombers doing training. And from that was this series of historical events that just kind of centered here on Tonopah. So you had the Red Baron, the fastest piston-powered aircraft, broke the world speed record for the fastest piston-powered aircraft. It flew out here. the X-15, which was the fastest aircraft ever built, a hypersonic aircraft that went into outer space, and Neil Armstrong got his astronaut wings with the X-15, crash landed on mud flats not too far from here. So it's so funny, it's a great place to start this journey talking about all these things in the sky, because just through serendipity and luck, Tonopah has found itself at the center of all this crazy aerospace history.
I'm excited. Should we get going?
Yeah, let's go check it out.
Taylor is a student of military history, rocketry, along with the Earth and space sciences. His work to expand applications for nuclear medicine and in reactor technology makes him a great guide for some of the science and history in this region. From Tonopah, we travel on Highway 6, continuing past its junction with the Extraterrestrial Highway, and after about 75 miles, we make a right turn onto the Lunar Crater Backcountry Byway. This is really cool.
That's pretty incredible, isn't it?
Yeah.
Just the sense of scale, right? It's an impressive crater.
You know, and it's kind of hard to really understand how big it is from the pictures, because
Yeah.
it's huge.
Oh, it's big, yeah. What's so neat is as you look around, I mean, this is all a relatively new volcanic landscape. So we're in the Pancake Range here, and you see some other volcanic craters and vents and lava flows out in the distance. So there's magma beneath our feet. And what you see out here are just different places where that magma has reached the surface. And sometimes, like off in the distance, you see that lava field out there. Sometimes it flows, and in some cases it explodes. You know, this stuff has erupted in the last couple 100,000 years, which in geological terms, it's all pretty new. You know, this volcanic field started erupting maybe 6 million years ago, and it had some period to it. Maybe every million years it had a series of eruptions. But we think this crater, Lunar Crater, is actually maybe 150, 200,000 years old. And what happened? I mean, what created a crater like this? Something absolutely catastrophic. Basically, how we think these form is you have all this magma beneath the ground. You also have groundwater, and magma and water don't mix.
Oh.
So you have this magma coming up, and when it hits that groundwater, it flashes it to steam. And that explosion, that steam explosion, is responsible for the crater. And all of these boulders and pieces of volcanic rock you see around us were blown out of this crater, and led to this incredibly beautiful landscape that you see around you. But you wouldn't want to be standing right here when something like that happened.
Well, and so this though has some more recent history too.
Yeah, absolutely. So obviously you look at this big crater, it's named Lunar Crater. You might imagine this looks like a crater on the moon. And well, NASA and the USGS thought the same thing. So when the Apollo astronauts were training for the Apollo missions, especially the later Apollo missions where they wanted to go and do geology and collect rocks, they needed a crash course in geology and what they would see when they go to the moon. And this was one of their best field sites. So NASA and the USGS brought not only geologists, but also the astronauts here to train both what it would be like to operate around craters on the moon, and also some of the geology and the rocks that they would see there.
So in your opinion, do you think this looks like another planet?
Yeah, I mean, it is definitely a vaguely extraterrestrial landscape. You know, what are the differences of this and a crater on the moon? Well, obviously no vegetation on the moon. Also, you know, the lunar regolith, the lunar soil is a lot finer, right? Because you don't have the forces that occur on Earth that conglomerate and round the material. So on the moon, it's all covered in kind of a fine powder. But take those two things away, and you could easily be standing on a volcanic crater or an impact crater on a different world.
So when you visit a location like this, what are the things that we can learn from a volcanic crater?
Well, there's lots of things. So obviously there's interesting geology, like the moon and Mars. These are the kind of landscapes that we see, and it tells us a lot about the formation processes that lead to the landscapes that we see. And they're also great training grounds. So not only the Apollo astronauts, but also some of the robotics and the rovers we've sent to bodies like Mars. This is a great landscape to test those out because it's what we call a planetary analog, or a place on Earth that we can simulate what it would be like to be in outer space.
So it's really cool that this is part of our landscape and part of Nevada.
Yeah, it's a very unique place. This has been named a national natural landmark because it's so unique and obviously beautiful. And you don't have to be a geologist or a planetary scientist to come here and be able to appreciate how incredible and beautiful it is. If you think about like the 3 types of craters you might find here in Nevada, we've got impact craters, right?
Right.
Most of those are older and kind of harder to find. We have nuclear craters, especially down on the test site.
Right.
Looks like the surface
big
of the
part of
moon.
Nevada history.
Oh yes. And then volcanic craters like this. Nevada is one of the few places in the world where you can find all 3 of those things, and all find them within maybe 150 miles of each other. It's a very, very rich geological landscape here.
And it's so interesting because you tend to think that those kind of fundamental geologic changes are more or less done.
Yeah.
Because we don't see them necessarily in our lifetime.
Yeah.
It's ongoing.
Oh, it absolutely is. I mean, this is in Earth's history of 4 billion year history, very recent, a couple 100,000 years ago. But there's activity out here that's even more recent than that. And we're about to go to where a nuclear test happened, and we'll see faulting that happened, in the last 50 years. So it'll be interesting to go check out.
I guess we better get going.
Yeah, let's do it.
It's tempting to head into the crater and explore more of this wondrous natural landscape, but that will have to wait for a return trip because there's more to see in the area. We head back west on Highway 6, and about 25 miles away from Highway 375, we turn onto dirt at Hicks Station Road. From there, it's a few more turns and about 12 miles of dirt road driving until we reach the Project Faultless test site.
In 1951, this old gunnery range, which became the Nevada Proving Ground, was selected as the on-continent nuclear test site. And for about 10 years, a little more than 10 years, that was where we did primarily atmospheric nuclear testing. So nuclear bombs of all kinds were tested out there in the atmosphere. President Kennedy signed the Limited Test Ban Treaty, and that was both a way to curb the arms race and slow down this race for bigger and bigger nuclear weapons between the US and Russia, but it was also a recognition of the environmental effects of these tests. When you tested in the atmosphere and the oceans and outer space, the radioactivity was in no way contained, and that led to a terrible offside or downwind cohort of health effects in the exposed people downwind. And so in what was a stroke of genius and wisdom, the US and the Soviet Union signed the Limited Test Ban Treaty. That meant all nuclear tests went underground. And throughout the 60s, these nuclear weapons tests were getting bigger and bigger. And the Nevada test site really is not that far from Las Vegas.
Yeah.
So you can imagine the residents were not too happy at the frequency and scale of these nuclear tests. That's why this test, which was a megaton, so maybe 70 times the size of the bomb dropped on Hiroshima. So imagine 70 Hiroshima-sized nuclear bombs going off at once beneath our feet. That's a very large nuclear device. So this shot in particular, Project Faultless, was a calibration test. They basically wanted to prove that this area here, north of the test site, would be viable for this very, very large yield nuclear testing. They named it Faultless as kind of a hope that it would be contained and not lead to any faulting or subsidence. And as you can see all around us, that was kind of an ironic name.
Well, and we passed that huge fault coming in too.
So you can imagine a megaton nuclear device going off triggered all of these natural fault lines around us and created essentially human-created earthquakes. And, well, the name turned out to not be true. So 3,000 feet below our feet was the emplacement shaft. So people actually went down this casing right here and mined out a cavity underground, and they took the nuclear bomb down and they detonated it. And when it went off, the ground surface was about, well, 10 feet above our heads here at the level of that casing. That was the ground level. And the ground dropped where we're standing about 10 feet.
So now, and I'm hearing some beeping.
Yeah.
This has been beeping consistently. So is that telling us it's safe to be here, or is this beeping a bad sign?
Yeah, so everything you're hearing is just background radiation. I mean, it's no different here than it is, 15 miles that way, which is a good sign. It meant that the radioactivity of that test was contained here. That isn't the case in all of these nuclear tests that happen at Nevada, but at least here, the radioactivity was contained.
It's so interesting to me that this exists out here, and yet so few people know about it.
Oh, absolutely, yeah. I mean, unless you're a nuclear history buff, or you just happen to drive by this large metal pipe sticking up,
right,
you'd probably have no idea. If you just think of the ground level being the top of that tube, you can really see, what happened. And it, again, maybe it was wishful thinking, but it's kind of ironic that they named this test Project Faultless. Because it did lead to quite a great deal of faulting. And they said, nope, this isn't gonna work. We gotta pack our things up and go up to Alaska. The Limited Test Ban Treaty not only slowed down the arms race, but it helped mitigate a lot of the, more, devastating environmental effects of nuclear testing. Traces of these radioactive elements like carbon-14, plutonium, cesium-137 are detectable now in the geological record from the advent of nuclear testing. Humanity created this almost unimaginably powerful technology that is nuclear weapons. And by doing so, it gave us the tools to make these kind of changes to the environment that were really only previously possible by acts of nature, acts of God. You can imagine if this was a megaton nuclear device that went off at the surface, how different where we're standing would be today.
As we head down Highway 6 to connect with the ET Highway, we stop for a moment at the historic marker for the ghost town of Taibo, which just happens to be near an auxiliary airfield and a group of buildings known as Base Camp.
This place is called Base Camp, and it's named that because it was the Atomic Energy Commission's base camp for Project Faultless and the Central Nevada test site. They needed a place to stage equipment and fly in planes and bring in all of the personnel associated with that test. And so that's what they set up here. They set up an airfield, some various hangars and building facilities. And after Faultless was more or less a failure and they abandoned the site, well, the airfield was abandoned too. But it was after that, in the following decades, that the United States government, primarily the United States Air Force Flight Test Center, said, oh, this is close to all of our flight tests that are happening in the Nellis Range, places like Groom Lake and the Tonopah Test Range. This might not be a bad place to have. And so now today is a detachment of this classified flight test. Those planes, those aircraft, those systems that are tested out there leave the range. And so, if you were standing here, 6 or 7 hours from now at night, and you looked up, you might have a good chance of seeing a UFO. Whether that's little green men, can't say, but at least it's something unidentified and flying.
We have time for one more stop, one that truly does have a galactic connection. We travel down Highway 375, continuing through Rachel and on to Hancock Summit. Our next adventure is embedded in the rocky face of the mountains in this area.
So what brings us here?
So here we are, we're at Hancock Peak. That's the Extraterrestrial Highway right there, 375. And that right there is the road into Area 51. And about 300 million years ago, something from outer space collided with the ground.
I'm guessing it wasn't a spaceship.
Probably wasn't a spaceship. So best we can tell, it was some kind of planetary object, maybe an asteroid or a comet. And somewhere that way, maybe 40 or 50 miles, it slammed into what at the time, a couple 100 million years ago, was an ocean, what would become the Pacific Ocean. So we were actually underwater 300 million years ago right here. But it was the shallow, is what we call the shelf. It's the shallow kind of reef area of what would become the Pacific Ocean. And something from outer space hit the ocean, hit that shelf, and it was cataclysmic.
So how can you tell that from this landscape?
Yeah, well, if you look at the rock here, you'll start to notice something very interesting. This is what we call the Alamo Breccia. And Breccia is unique because you'll notice it kind of looks like a conglomerate, but lots of really sharp edges to the material inside of it. And that is because that's our first indication this is something very cataclysmic. So what we think happened, impact happened, caused a massive tsunami of ejected material, and that ejected material is what now composes what we call the Alamo Breccia. And the breccia is a kind of, think of it like a sedimentary rock that has a lot of different materials inside of it. You might have been on a hike and seen conglomerate before, where you have like little pebbles, like rounded pebbles in a
Almost
matrix.
looks like cement.
Exactly. That's conglomerate. That is a more traditional sedimentary process that creates those kind of rounded rocks inside a matrix. This is a lot cooler because this has these very sharp edges, which again tells us that the process that created it was very violent, right? You had this ejected material from a crater, somewhere probably that way, that created the tsunami of material that then deposited here in this layer that we call the Alamo Breccia. And when it consolidated and formed the rock layer you see here, it has that little pieces of the reef, in some cases big pieces of the reef, that got ejected from the crater off in the distance. It's really cool. You'll see these marine fossils of different organisms, including conodonts, shells, other, interesting organisms that were, living on the ocean floor that have, met their demise inside the breccia.
So some of them that are kind of round and almost shell-like could be shells.
Yeah, absolutely. It ranges from little pieces to massive pieces. I mean, some of these are as big as a car.
Yeah.
And that really shows you the force of this impact. Even though the impact was probably, tens of miles or farther that way, that was able to pick up this debris and scatter it here. Oh, this is interesting. You can, if you want to take a look here, there's corings. So you may wonder why there's all these holes in the rock, but the geologists have come out here and taken little cores of the rock
Samples.
to take back to the lab and analyze for, again, ejecta materials, traces of iridium, maybe the fossils that are inside. And that's what's so cool about geology is you see these rock layers, and each rock layer tells a story, right? It's a story through time. As you go deeper and deeper down into the rock, you're going deeper and deeper into time.
What an amazing day of science.
Yeah, who would have thought on the Extraterrestrial Highway you'd find so much science?
And real science.
Yeah.
Well, thank you for bringing me out here.
Thanks, Chris.
It's been a great day. That's all I've got time for in this episode, but it has been out of this world getting to explore more of the Extraterrestrial Highway through southern Nevada and learn real science, history, and geology along the way. If you want to learn more about this Wild Nevada or any in the series, visit our website at pbsreno.org. Until my next Wild Nevada, I hope you get to have some cosmic adventures of your own.
Support for PBS Reno and Wild Nevada comes in part from the William N. Pennington Foundation. Bill Pennington was an entrepreneur, philanthropist, and gaming pioneer who built a legacy of community service in Nevada.
And by Thelma B. and Thomas P. Hart Foundation, Christine Perry, Margaret Burback, Mark and Susan Herron, in memory of Sue McDowell, Lloyd Rogers and Gaia Brown, Stanley and Neela Schumacher, and by individual members.